Hi students, in this video we're going to take a look at the constant operation mode on the calculator. This function on the Sharp calculator is denoted with a K up here on the right side of your calculators. This function is useful when a factor is repeated in a problem. Let's look at the demonstration problem on page 46. On the left you can see that the hourly rate factor is the same for each of these multiplication problems, but the number of hours worked are different. When doing multiplication, the constant factor, that is the factor that's the same, must be entered first. So let's engage our constant function and key this problem together. Now this problem is involving dollars and cents, so I'm going to set my decimal selector at 2. And I'm going to key in the constant factor first. And the constant factor here is the hourly rate. So 3.96 is the hourly rate. And when I key that in and I press the multiplication key, that entire amount is saved as the constant. In other words, it is not just putting in 396, but rather it is showing that 3.96 as well as the multiplication sign, that is being stored as the constant. So now what I'll do is I'll put in the hours worked, 8, and press the equal key. Notice that a K will appear on your tape. That shows that the constant function is engaged. Now, for the next problem, I don't need to key in 3.96 times again. That's already saved in there. All I need to key in is 16, the second factor, and equals. And then the next problem has 32 hours, equals. The next problem, 37.5 hours, equals. So what I've done is by keying in that constant factor first, right here, what I've done is I've saved myself from having to input that over and over again. So I just put in the hours, the second factor, I get my answer. As the hours change, I key that in, get a different answer, etc. So that's how the constant key can be really beneficial and time-saving device in doing multiplication where one of the factors is constant. In division, you can also have a constant factor. When you're doing division, the constant factor or the divisor must be entered second. So this holds true regardless of how the information might be arranged in the problem. You've always got to set up the constant divisor as the second thing that you enter. Let's take a look at the demonstration problem on page 50. So on page 50, we have annual salary amounts that vary for these various individuals, but the constant factor is 52. In other words, we want to find out for these employees how much their weekly salary would be if their annual salary is, for instance, $17,220. If we divide that by 52 weeks of the year, we get a weekly salary. So let's take a look at doing this with the constant factor, or the constant mode. So we've got our constant engaged. So I'm going to enter 17,220, and then the division key and the second number that I enter, the divisor, become the constant, and I press the equal key. So now I don't need to enter divided by 52 again. I just need to enter 22,140 and hit the equal key. And it is dividing it by that 52, that constant. Then I do the next one, 25,630, hit the equal key, 28,400, equal key, 33,390, equal key. So you can see that this constant factor for multiplication and division problems can be a real time-saving device. Hi students, Lesson 8 presents the concept that when we're dealing with invoices, many times small items are sold in a certain group. And so we're going to go over some shortcuts or symbols that are sometimes used to designate groupings of items, and also just discuss the fact that it's an important aspect to pay attention to, because the grouping of the item of quantity may not exactly coincide with the way that prices are quoted. Let's look at some examples. One that we're quite familiar with is a dozen. We know that a dozen is a grouping of 12. What you might never have been exposed to is the concept of the term gross. A gross is a unit or grouping of 144 items. And that is sometimes used for small items such as pencils or something of that nature. M, the Roman numeral, stands for a grouping of 1,000. C, again Roman numeral, stands for the grouping of 100. And then we use the term ream to generally in association with sheets of paper. So there would be 500 sheets to a ream. So it is really important that we pay attention to the quantities on the invoice versus how the prices are quoted. As an example, let's suppose that prices are quoted per ream for paper, and I need to purchase 3,800 sheets of paper. So I need to figure out how many reams there are in 3,800 sheets. So I'm going to take 3,800 and I'm going to divide it by 500. I learned that there's 7.6 reams. Had the grand total engaged, didn't need to do that, I'm going to take it off. So there's 7.6 reams that, that I'm going to be purchasing. If the reams, let's say, so we've got 7.6, 3,800 sheets converts to 7.6 reams, and let's say I'm quoted a price of $5, so $5 per ream. So I've got 7.6 reams times $5, that is $38 that it's going to cost me for what I want to order. Now, in fact, I might only be able to order it by the ream, so that's another consideration. But at any rate, recognize that often on invoices, items are grouped together, and so we have to pay attention to how the quantity is specified and does that coincide with the price that we're given. If not, we might need to do some math to get there. Hi students, in this video I want to demonstrate multiplying 3 or more factors. The multiplication of 3 factors is a problem that can be done in 2 ways. One way is called continuous multiplication and the other way is called non-continuous. Let's take a look at pages 54 and 55 and I'll demonstrate first continuous or chain multiplications as it's sometimes called. So we have 3 factors, 38, 72, and 0.98. We're going to first enter 38 times 72, and then times again 0.98 and equal. So we have continuously done the chain multiplication by keying in the first factor, the multiplication key, the second factor, the multiplication key, third factor, and then the equal key. Now we can also do this in what is considered the second method, or the non-continuous. And that is by way of keying in the first factor and then hitting the multiplication key and then keying in 72, and then here we would hit the equal key. So we would get the answer, if you will, to those multiplication of those first 2 factors. Then we would take that answer, press the multiplication key to enter it, key in 0.98, and press the equal key. So that demonstrates how we can do multiplication of 3 or more factors either continuously or in this non-continuous fashion. Hi students, in this video I want to address how to determine the number of required decimals in a problem. To do this, I'd like to take a look at the demonstration problem on page 56 and use that to help show how to determine the required number of decimals. Let's take a look at this problem. We have 1.6 times 31.2 times 9.47. Now there's no dollar signs in that, so we actually have to count the number of decimals that will be required in the answer by adding up the number of decimals in the problem. So we have 1 decimal place, 2, 3, and 4. Therefore, the answer to this problem needs to be 4 decimals. Now, if there were a dollar sign associated with any of these, automatically we would say only 2 decimals in that answer. But because there's no dollar sign, we count the decimal places and we're going to take this answer to 4 decimals. Now we can either set our decimal selector here at 4 and let the calculator do that for us, or we can put our decimal selector on float. We would see the maximum number of decimals in the display, and then in writing down our answer we would round it to those 4 decimal places. One of the reasons that you might want to leave it on float is when you end up doing problems where the number of required decimals varies from one problem to the next. You don't want to have to be changing your decimal selector for each and every problem. So one way of doing it is set it on float, then pay attention to the number of decimals by either counting them or rounding to 2 because there's a dollar sign in the problem, and that way you're manually doing your rounding and you're not having to change your decimal selector for every problem. So here we've got the decimal selector set on float, so let's go ahead and do this problem. 1.6 times 31.2 times 9.47 equals. Now, it just so happens that although I had my decimal selector on float, notice that my tape shows only 4 decimals. That's because the other decimals are zeros. So if they'd been anything but 0, they would have shown up on the tape. So the answer to this problem would then be 472.7424. Again, remember, if there's a dollar sign in the problem, that means only 2 decimals. Otherwise, you may need to count the decimals in the problem to figure out the number of required decimals for your answer. Hi students, in this video we're going to be discussing and demonstrating mixed operations in continuous process using the calculator. You've learned that after entering positive numbers, addition, and negative numbers, subtraction, that you must press the total key here to get the answer. Pressing the multiplication key or the division key after the total key will take that total and use it as a factor for multiplication or division. Let's take a look at the demonstration problem on page 60. I'm going to clear my calculator. In this problem, we are combining 25, which is a positive number, with 18, which is also positive. Then we're going to subtract 19 from that. We want to do those operations in the parentheses first. And then we're going to take that answer times 4. So let's do that on our calculator using continuous process. 25 would be entered as a positive, 18 is also a positive, 19 is entered as a negative, and now we're going to total or combine those numbers. Now we have the answer to that problem in parentheses. We're going to take it times 4, and that would give us the answer of 96. So notice that your tape shows that you've done the operations in parentheses first. By pressing the multiplication key, you took that answer, multiplied it times 4, and got your final answer. So this is an example of doing mixed operations in continuous process. Okay, this is take 2 on lesson 10. Hi students, we are focusing on lesson 10, and the business application I'd like to turn your attention to is on page 62, where you're going to use a sales summary report to practice your skill of engaging the grand total function and using it to apply cross-footing for that particular problem. So please use your new skills on that problem and demonstrate how that grand total can be engaged and used for that problem. And then we're going to take a look at multiplication or division followed by addition or subtraction. So turn to page 63, and I'd like to take a look at a couple demonstration problems. Let's take a look at this problem first, where we have multiplication of 15 times 12. We want to combine that answer with a negative 25. Let's do that on our 10 key continuously. First, we're going to do the operations in parentheses. 15 times 12 is 180. 180 gets entered as a positive amount, then 25 as a negative amount, and we total those two to get 155. And we've done it in a continuous fashion. Let's do the next one. Remember, we're going to do the operations in parentheses first. So in this case, we're going to take 156 divided by 13. We get the answer to that. That answer is going to get combined with a positive 25, and the answer to that problem is 37. So we have done multiplication or division followed by addition or subtraction in a continuous fashion. Hi students, there's one last concept I want to cover with you in lesson 10, and that is applying continuous operations to complete a payroll register. So the business application problem that we're looking at is on page 65. We're going to take the number of hours that an employee worked times the rate of pay per hour. We're going to calculate gross pay, then we're going to subtract deductions and calculate net pay. So let's do the first step. 39.75 hours times 5.75 per hour equals $228.56. Now, from that, we want to subtract 19. So with the answer on the display, we hit the plus key so that we can combine that positive answer. We key in 19 with a negative 19 and then press the total key. So you see that we have calculated gross pay and we have calculated net pay in one continuous calculation. Hours times rate equals gross pay. Gross pay gets entered as a positive. Deductions get entered as a negative. Deductions reduce gross pay, and we calculate net pay. So we're filling out this payroll register using continuous operations. Hi students, we are going to go over the concept of a cumulative multiplication. This lesson introduces you to the blue memory keys on the calculator. Now it might be that your calculator has memory keys in a different location, but you will need memory keys in order to do the cumulative multiplication. So the memory keys allow you to enter into memory a number as a positive by hitting this key, a number as a negative by hitting this key, subtotaling combination of positive and negative numbers with this subtotal key, and then totaling your memory with this one. Notice that this machine uses consistently the diamond shape to denote subtotal, both here on the memory keys and here on the main machine, and then the asterisk key denotes a total, just as it does here on the main keyboard. So we're going to use these memory keys, and be able to combine different numbers in the memory. Let's take a look at a demonstration problem on page 67. Here we have quantities and prices like you would find on an invoice. So let's take a look at doing the extensions and the total using the memory keys. Now we've done this using the grand total in the past, but I'm going to show you how to do it using the memory. And then you will recognize that you could use either function and accomplish the same task. So our other functions are disengaged. We're just going to be using the memory keys for this demonstration on page 67. So I have 5 watches at 29.95 per watch. So I got the extension, and I'm going to put that extension into memory as a positive. Then I'm going to do the next extension. 3 times 49.95. I'm going to put that into memory as a positive, and then 7 times 59.95. That also goes into memory as a positive. Now I want to total each of those and get my invoice total. So you'll see that the tape indicates that each time that extension went into memory, I see a plus I, added it to memory. So the first extension was added to memory here, the second extension was added to memory here, and then we end up with our total. Oh, here's our third extension, and then our total for that invoice. Let's do that same problem using the grand total function, and then you'll be able to see the difference, how the tape looks different, how the tape will show you that you're using the memory key versus the grand total key. So I'm going to, oh, incidentally, when I do press this total key for the memory, it not only totals it, but it clears it. So I'm going to do this problem again using the grand total function. So I've engaged the grand total. 5 times 29.95, and then 3 times 49.95, 7 times 59.95. Each time I pressed this key, it took that extension and put it into that grand total memory. Now I just need to total. So take a look at how these tapes are different. This one in my right hand is using the grand total, and this one in the left is using the memory keys. Same problem, just different techniques, and they both work. Hello students, this video is focusing on negative multiplication, concept brought out in lesson 12. Negative multiplication simply means one multiplication product or answer is subtracted from another. Let's review the demonstration problem on page 76. So we have this problem. We want to take 15 times 11, subtract that from 8 times 8. So what we're going to do is first we're going to key in the multiplication problem 15 times 11. We're going to get that answer. Now that positive answer is going to need to be combined with this negative answer. So I'm going to put that answer into memory using the plus I key. Now I'm going to do the second multiplication problem. 8 times 8. That answer is 64. That needs to go into memory as a negative because we're combining this negative with this positive. So I'm going to go ahead and enter that into memory as a negative. Now what I'm going to do is combine this positive answer with this negative answer by hitting the memory total key. And we have in fact done negative multiplication using the memory. 15 times 11, that answer went into memory as a positive. 8 times 8, that answer went into memory as a negative. And then by hitting the total key, we combined those two answers. You can skip page 77 and the steps involved in doing negative multiplication on a calculator without a memory, because I really want you to be using a calculator with a memory so that you understand those functions. So we're not going to focus in on the calculator without a memory. On page 79, you may actually do those problems using either the memory or the grand total function. So maybe do it each way and decide which method seems to resonate the best for you. Let me show you a couple tapes of these problems being done with the memory versus the grand total. So here we have the problem being done. Again, this is page 79. First, we're going to show it with the memory. So we would take the quantity of 4 gallons times 1098, the price per gallon, and we get the extended amount. We put that into memory as a positive. Take 2 gallons times 898, put that into memory as a negative because that was paint returned, and then we combine it into memory by hitting the total key. Now this could also have been done using the grand total function. 4 gallons times the price per gallon, and with the grand total engaged, it would have put that total into the grand total. Then we could have, on the second extension, taken 2 gallons times 898, and by pressing this red minus equal key, that would have put the answer to that second multiplication problem into the grand total as a negative, and then we just hit the blue grand total button. So 2 different ways of doing the same problem, both equally acceptable.